Hello and welcome. This is going to be our lecture video to go with this worksheet here. Let's go ahead and get started. Newton's third law states, so A, objects in motion stay in motion and objects at rest stay at rest. That's actually his first law. B, force is equal to mass times acceleration. Well, that's actually his second law. Or C, for each action, there's an equal and opposite reaction. I agree with C. I'll let you explain why for all of these. All right, an archer shoots an arrow. The action force is the bowstring against the arrow. The reaction force is blank. So if the bowstring is going to push against the arrow, then the arrow should also push against the bowstring. That's almost exactly what B says. You just have to swap the two objects. So if it's the bowstring against the arrow, then there should also be arrow against bowstring force. All right, a player catches a ball. The action force is the impact of the ball against the player's glove. The reaction force is, let's see if we can get this one by just swapping them. So ball against glove should become glove against ball. So the force of the glove on the ball, that is option A there. All right, and then player's grip on the glove, no. The friction of the ground on the player's shoes, no. That might be a reaction force to something else, like the force the player exerts on the ground, but that's not the one that the action that the problem is talking about. All right, number 4, a player hits a ball with a bat. The action force is the impact of the bat against the ball. So let's try flopping this around. The reaction should be the ball against the bat. Let's see. And that is option C. All right. Number 5, baseball player hits a ball with a force of 1,000 newtons. The ball exerts a reaction force against the bat of 1,000 newtons. That's a very important part of Newton's third law. It's equal and opposite. So here we see that it's equal. And in the opposite direction, the ball is forced maybe to the right, while the bat might be forced to the left or other way around. Number 6, a person is attracted towards the center of the earth by a 500 Newton gravitational force. The force that the earth is attracted towards the person is also 500 newtons. You're being pulled down by the earth, but you are also pulling up on the earth. It's just the earth is much more massive and therefore much harder to accelerate. All right, on to the back side where we're diagramming some action-reaction pairs. Let's look at the first example. Fist hits the wall, and then the wall hits the fist. So hits isn't a great physics word here. It's really be exerts a force. So the fist exerts a force on the wall, and then the wall exerts a force back on the fist. Also, I don't love how these arrows are. I'd much rather get rid of this arrow and show it right underneath this arrow, or other way around. I could have slid the other one over, but I like them to be a pair like this so that we can see they're the same size and see that they're parallel. All right, so now we've got this person headbutting a soccer ball. Well, as they exert a force up on the ball is going to exert a force down on them. There, let's make those parallel. And then the ball bumps the head. Although really it exerts a force down on, but we could say bumps. All right, windshield hits a bug. So it exerts a force to the right on this bug, but the bug, even though small, exerts a force to the left on the car. That's not my best arrow. So I should just see a parallel arrow going back this way. We can say the bug hits the windshield. And technically the car would be going a little bit slower because of that. It might be so small you couldn't even measure it, but running into that bug did slow the car down. All right, bat hits a ball. We see that there's a force from the bat on the ball. The force is going to the right, while the ball is going to push back on the bat to the left. So the ball hits the bat. Hand touches nose. We'll push back. Nose touches hand. Hand pulls a flower. Then the Flower pulls on the hand. Athlete pushes a bar upwards. Well, on both of these, we're going to see that the bar pushes the person down. Compressed air pushes on a balloon surface outwards. All right, and at each of these vectors, there's infinitely many of them around the ball. We see the air is, do that in the wrong direction. The air is pushing out, and then the balloon is pushing back in. So the air pushes the balloon, and the balloon pushes back on the air. Time to come up with your own example. Maybe I'll do something like an airplane. So let's do my best to draw an airplane here. All right, the airplane is going to have a propeller. And that propeller is going to blow air backwards. And then the reaction force is that the air pushes the plane forwards. So a propeller forces air backwards, and the air pushes the plane forwards. So the plane is taking advantage of a reaction pair by using a propeller to push air backwards. The air then pushes the plane forwards. All right, that'll be that for this lecture video. I'll embed a few more questions here. Have a good rest of your day.